All right. Good morning, everyone. Welcome to the Almond Board's Training Tuesday, Managing Warehouse Pests. We have some great speakers here that have put together some up-to-date content and hope you learn lots and enjoy. So to get us started, we have a few housekeeping to go over just for Microsoft Teams. Everyone will be muted and that their camera's off. I highly encourage you to pose your questions throughout the training, and we will go over those during our QA session. However, during our QA session, you will be able to unmute and ask your questions verbally and kind of create a conversation if wanted. And then for this course, we have CCA credits, Integrated Pest Management, that's 1.5 hour, and DPR, which is 1 hour of other. Be sure to stay attending and do not leave early because at the end of the course, we'll have QR codes for you to gain your credit. And for DPR, they do allow or require us to do a final examination since it's a virtual course. So there will be a 10-question quiz after this training. And I'll give more information about that towards the end. And then next, I would like to hand it over to my colleague Gabrielle, who is our Director in Environmental and Sustainability Affairs.
Yeah, good morning, everybody. Thanks for taking the time to attend this Training Tuesday about facility pest management. And just to give you a little bit of framing for why we wanted to talk about this, one is just simply it's not an area of pest management where we have a lot of our traditional advisors. So, for example, UC Extension folks or the PCAs. So trying to find good advice is part of the issue. The other issue is just simply given the volume of nuts grown, we have more nuts that are being stored longer. So just trying to make sure that folks are aware of what the tools are that can help them in maintaining the quality of those nuts during storage. And then I will be bringing up some MRL issues around post-facility use pesticides, just to keep that in mind as you're making pest management decisions. And with that, I'll just introduce our three speakers, plus myself. First up is Ed Hosoda. He's with Cardinal Professional Products and has been with them for 49 years. And so if there's a storage pest problem, he's your man, though he is trying desperately to retire. But there's a reason why he hasn't been able to, because he is truly one of the experts in facility and post-harvest pest management, stored pest management. He has a bachelor's degree from University of California, Davis. And I really don't think I need to say more than really he is the expert on post-harvest pest management, certainly in tree nuts. James Miller is with Tracy Incorporated. He's the market manager for the product StoreGuard, which he'll be talking about, as well as Sidetrack, mating disruption systems for post-harvest situations. Tracy is based in Oklahoma, though most of the people I know or I'm familiar with tend to be on the West Coast. And James brings 18 years of practical field experience, operations, and management in the space of post-harvest pest management. And then our third speaker is Vijay Pai from Sutera. He started his career working with SC Johnson, also working on facility or at-home pest management products such as RAID, which most of us are familiar with. He recently joined Sutera to lead and launch their newly formed commercial pest division, which brings Sutera's innovative pheromone solutions to the residential and commercial pest control markets. And then just to add myself to the mix, as Miranda said, I'm Director for Sustainability and Environmental Affairs at the Almond Board, and you're sort of sitting, well, how's that title fit in? Well, that environmental affairs also includes regulatory issues, particularly around pesticides. I've been with the Almond Board some 16 years now, and split my life between somewhat in the research program or production side, not the post-harvest side, the regulatory world, environmental regulations, as well as sustainability. So with that, I'm going to hand it to Ed to get us started.
Thank you, Gabrielle. Let's see. Can you see my screen?
Yes, so you want to put it in. Yeah, perfect.
Okay. Good morning, everybody. It's kind of difficult to talk about pest management in 20 minutes, but I'm going to try to do my best. I've got a lot to talk about in that time frame, so we'll get started right away. So first of all, we want to talk about pest management and why it's important in the food industry. Talk a little bit about IPM, integrated pest management, how identifying the specific pest is critical in your pest management program. Talk a little bit about biology of the pest, choosing the right pesticides, and then always evaluating your pest management program. Well, why? Why do we do pest management? With FSMA, the Food Safety Modernization Act, you have to be proactive about pest management instead of reactive. And the four-letter word in the food industry is adulteration. And you can have food adulteration in a lot of different ways from various pests, whether they're insects, rodents, birds, bacteria, or other forms that can cause food adulteration. So, for example, with insects, you can adulterate food products in a lot of different ways. With insects themselves, if you have a certain amount of insect counts per gram of food products, it can be adulterated. Insect fragments, um, frass or feces, the silk from the insects. Birds can contaminate food products in a lot of different ways, being their feces or excrement very filthy. You can get a lot of diseases or viruses from bird feces, such as psittacosis. And you can see here in the middle picture how filthy feces can be. Rodents can contaminate food products in various ways. Rodents themselves, rodent parts, rodent hair, feces, and rodent urine, as you can see under black light here. Um, a good tool to use for detection of rodent urine. It fluoresces under black light, or rodents themselves contaminating food products. So when you put together an integrated pest management program, the first and foremost, most important part of IPM is sanitation. A clean facility, fewer pests. That's the bottom line. So you've got to keep the cleanest facility that you possibly can. Sanitation is the most important part of IPM. I'll talk a little bit about exclusion, monitoring for pests, then using various control methods, and then how to evaluate your pest management program. Identifying the specific pests is critical when you're creating your pest management program. For example, up here in the upper left, that's a roof rat. A lot of baby roof rats will pass as house mice, but they're very different in how they could infest your facility. Roof rats you tend to find up in higher regions of your facility. And then when you look at smaller rodents, a lot of people mistake meadow voles for house mice. Then meadow voles may be coming in from outside of your structure in a field that they just recently cultivated. I've got a customer or client that were capturing up to 300 meadow voles in their facility a day because they just disked a 10-acre parcel right next to their facility. So they were all migrating indoors. This is a Norway rat, which is similar to a roof rat, but the roof rat's tail is long for balancing because you find them in high regions or walking on power lines. They use their longer tail for balance. A roof rat will have smaller ears, but they can be very large in size. Now, if you find little larvae crawling around your facility, you can identify sometimes what species of larva it is. I'll talk about that in just a little bit. Indian meal moth is one of the most common insect pests that you'll find in the almond industry on the post-harvest side. They're pretty easy to identify because they have this copper-colored wing cover here. Um, So Indian meal moth is pretty prevalent in our industry and easy to identify. Red and confused flower beetle is a primary pest in the almond industry, and I'll talk a little bit about that. And if you find a small insect crawling around your facility, you might think it's a sawtooth grain beetle, but it could be lictus. Lictus is a wood-boring insect, and they're commonly mistaken for sawtooth grain beetle. But the lictus beetle, the source of the infestation is from wood products. And then, of course, birds. Hopefully, you can identify a bird. So, talking about a little bit about the biology that would help you in identification of stored product insects. Red flower beetle versus confused flower beetle. They look virtually identical with a couple of different exceptions. The red flower beetle has on the distal end, on the end of their antennae, you have these segments here, but the last three nodules on the antennae are about the same size. Whereas with the confused flower beetle, you have a gradual increase in the size of those nodules. So why is that important that you identify a red flower beetle over the confused flower beetle? Because the red flower beetle flies. So when you have these two insects crawling around, you can actually most likely identify them with the naked eye because the red flower beetle appears like you have a little knob on the end of the antenna. So if you look at these two insects, you can tell that right up here, you got some knobs on the end of the antenna. This is the red flower beetle, and keep in mind that it flies, so it can infest the rest of your facility much quicker than the confused flower beetle. So it's critical that you identify one from the other. Looking at temperature and activity of insects, this is 65 degrees Fahrenheit, and these are flower beetles inside these fog check cards. We use these for bioassays for looking at efficacy of fogging insecticides. But here, these insects are 85 degrees, and you can see the increase in activity. So the warmer it is, the better the control you're going to have with fumigants and fogging insecticides. The cooler it is, the less control that you're going to have. Um, and you can compensate for the colder temperatures with certain products, such as with Profume, fumigant. You can increase the dose at lower temperatures to get efficacy. Same thing with fogging compounds. Um, Lower temperatures, you increase the rate of application. If you see little larvae crawling around your facility and you're curious as to what species it might be, well, one easy way to whittle it down a little bit is to look at the larvae. And if it's a beetle larva, you have the 6 legs up near the head, but no pro legs like you have with moth larvae. So with Indian meal moth, you can see the pro legs here. They're like little peg legs. So if you have larvae crawling around, you turn them over, look at the underside of them, and see that they have pro legs, and it's a moth larvae, most likely in a almond facility, it's Indian meal moth. If you have something like this is red or confused flower beetle. Just to give you an indication of how quickly population can grow, if you start off with 400 eggs from a female, those eggs within 3 months of a period of time can create up close to 6 million eggs, 1.7 million females, and about 3.5 million total insects. That's how quickly insect populations can grow under ideal conditions. So you can go from a low population to an explosive population within a fairly short period of time if you don't have a good pest management program in place. You can look at the biology of insects. We call it the circadian rhythm of stored product insects. So for example, this is Tribolium castaneum, red flower beetle. They have a tendency to fly at about 6, depending on the time of the year. Basically, when the sun sets, they're very active in flying. Or the red flower beetle flies, remember. So about 6, 7 p.m., when the sun's starting to go down, they get very active. Well, in this particular study, they were fumigating piles of rice, and they were tarping the rice and fumigating it, and they kept having poor control. Well, the problem is that the red flower beetle were flying at the time that they were tarping the pile, so they were all above the tarp flying around, and they fumigated here at this time, and they were getting a lack of control because many of the insects are flying above the tarp. So that would be a good time to fog when they're all active and flying, but not a good time to fumigate. So they resolved this issue by fumigating actually 2 o'clock in the morning, where they would tarp the pile. Most of the insects are in the commodity at that time, and they get a successful fumigation. Understanding the biology of insects can also help when you look at the eggs of various insect species, like the dried fruit beetle has only one aeropile in it. That's where they breathe. And the dried fruit beetle can be very difficult to control under many circumstances, whereas the navel orangeworm at each one of these cross-sectional areas is an aeropile. They can be, depending on the product that you're using, they can be a lot easier to control in the egg stage. Talk about exclusion of pests. There are all different ways that you can exclude pests here. This is a great example of how not to use door strip curtains. Insects can fly in, birds can fly in. You want to make sure that they're in good working condition and not kept back like this. Most people hate plastic door curtains, but here we have air curtains. You want to be concerned about the negative pressure that you might have within the facility. When the air curtains are blowing and the doors are open, if you have negative pressure in the facility, it could just blow the insects right in. Excluding rodents, make sure at this area here, it's flush with the ground, or you don't have any openings like this, or you keep vegetation away from the building. Ivy is a great place for rodents to be living and breeding and gain easy access to your facility. Boneyards, old equipment, keep them away from buildings. You'll find lots of rodents harboring in these types of areas. And then birds, you can't see it very well here, but there's bird netting. If you don't do a good job with netting, birds can actually get in. They're stupid enough to get in, but not know how to get out. And a lot of times you'll find bird carcasses on the other side of the bird netting. Here's an example of using irritape, like Mylar type tape, which flashes in the wind and can keep birds away from areas that can be a very effective tool to use for bird exclusion. Monitoring of pests is critical. Looking at making sure that you have a painted white stripe so that you can easily see insects or rodent droppings in your facility. So keep a nice, at least 2-foot space, minimum 18 inches, preferably 2 feet, paint it white so that you have a good inspection strip and a place for rodent stations within your facility. Here's an insect light trap of a facility that was fumigated in South Carolina, cigarette beetle. This is the insect tray from an insect zapper, just loaded with cigarette beetle. Pheromones, like Trace's product, they make some excellent pheromone traps for monitoring various stored product insects. Using a black light for detection of rodent urine is helpful. Observing 9 within your facility, indicating rodent activity, and then of course bird droppings. So creating a pest management program, identify the specific pests that you're dealing with and what the population density is from your monitoring procedures. Make sure that you keep as clean a facility as possible. Target that particular pest with specific products that would be efficacious for that specific pest. Use your control method. So all of these items you need to put together to create a good pest management program. So for example, if you have Indian meal moth in your facility, you know the exact pest that you're going after and you understand the biology. This is the female emitting pheromone. And put into place Jim's sidetrack Indian meal moth dispenser that emits sex pheromones, so it confuses the male. Jim's going to talk about that. It's a least toxic material that you can use and get very effective control. So you're going to hear a lot about mating disruption here in just a little bit. Extremely effective tools to use for controlling Indian meal moth. Then you can look at sprayable residual insecticides. There's a lot of different ones, like Tempo's been around a long time, Fast Cap, Terminador, but you want to make sure that you choose the right formulation. There's all different types of formulations. Going back years ago, we used to use a lot of emulsifiable concentrates, but they're probably the worst product to use spraying on concrete, because concrete can just absorb the product. So you might want to consider using a product like Tempo, which is a wettable powder, or Fast Cap, which is a microencapsulated product, which stays on the surface of the sprayed areas to control the insects after a long period of time. ULV insecticide products. There's a lot of different products available that you can use, whether it's DDVP, pyrethrin-based products, synthetic pyrethroid products, insect growth regulators, or even Trace's new Sidetrack IMM MEC. It's a product that you can spray or fog for mating disruption purposes. So there's a lot of ULV insecticide products available in the marketplace that are extremely effective. IGRs, there's different IGRs that you can use: Nigard, pyroproxyfen, Diacon, which is methoprene, and Gentrol, which is hydroprene. But these are larvae that were affected by the presence of IGRs. They're not an adulticide, but they interrupt the life cycle of stored product insects. So very effective at extremely low concentrations, and fairly safe to use in a food environment. If you need to use a fumigant, choose the right fumigant. There's a lot of fumigants that are available, from aluminum and magnesium phosphide to methylbromide for quarantine or pre-shipment uses, Vapor Phos, EcoFume, and then Profume. A lot of different fumigants available, but choose the right product to use depending upon the circumstances. And then use the right dose. Follow the label recommendations. Keep in mind the exposure periods that the particular product recommends. There are certain products where you have to look at the temperature and specific target pests. For like Profume, their Fumiguide software program, you enter the specific target insect that you're going after and the temperature and your exposure period, and then it tells you exactly how much fumigant that you need to use under those circumstances. And then Gabrielle's going to talk about MRLs, but whenever you use a pesticide, you want to make sure that you're aware of the residue tolerances depending on the pesticide, the commodity, and the country that you may be exporting to. So she'll talk about that a little bit. Understand the deficiencies of the various pesticides. So for example, this is phosphine, and we find that in-shell almonds, you can get up to 100% absorption of phosphine fumigant into in-shell almonds. So it takes away the availability of phosphine fumigant to control the insects. So you're going to have to continue to add more gas in order to get good control. So you want to understand what the deficiencies are on these various pesticides that you're going to be using. Then we have organic products that you can utilize, carbon dioxide being one of them. It's a newly registered product called IGI-CO2. It's certified for organic use by the Washington State Department of Agriculture. There's a lot of different commodities on the label. And what you need to do is target 60% concentration for a minimum of 4 days to control all life stages of the stored product insect. And we have automatic dispensers available that'll maintain 60% concentration over that time frame. You can look at using Evergreen as a fogging or spraying agent on organic products, which is also certified for organic use. And we have issues with certain products such as phosphine. We're starting to see resistance formation with phosphine. So there's a lot of research going on. Like here, this is Dr. George Oput, Oklahoma State University. He did some research and published this paper about using phosphine for controlling red flower beetle and a sawtooth grain beetle. That he found specific dose requirements in order to control all life stages of the insects. So be aware of some of these deficiencies that we have, and find out what is exactly required in order to get good control of these insects, depending on the product that you're using. And then you can actually drill down even more and look into some of the research that's done on insect growth regulators. There are some insects that are not so susceptible to IGRs, Indian meal moth being one of them. You can still control them, but they don't get controlled as well as red flower beetle. Red flower beetle are very susceptible to most of these IGRs. So you'll find research studies like this available out there that'll help you with your pest management program. So the fifth component of IPM is evaluation. You always want to evaluate your pest management program. Learning as much as you can about the pest, the products that you're using is critical. Inspection and monitoring of the pest and how well you're doing with your pest control program, making sure that you keep a clean facility, and then using the pesticides, which is really the smallest part of your pest management program, is using the minimal amount of pesticides in your program. So looking forward, education, stewardship of products, pesticides, and research is critical. IPM focusing on minimal use of pesticides, using precision application technology such as we do with Profume and Sidetrack IMM, using the greenest technology available. And we're now talking parts per billion with our pesticides and how effective they are at very low concentrations, such as with insect growth regulators. So that's a lot to cover in 20 minutes, but it's 20 minutes now, so we'll keep, I guess, questions till the end.
Thank you, Ed. That was an amazing, quick overview of what it takes. Appreciate it. So now moving on, and Patrick will address your questions at the end. James. James, are you able? Yeah, okay.
All right, how's that? All right, all good. Cool, I'll start my timer here. So I like to always emphasize the philosophical educational side when we're doing this, and that's exactly what this workshop is designed to do. So we'll pay attention to that of the philosophical needs of controlling Indian meal moth in almonds. Is easy if you use mating disruption in general. So ask questions you need to. We're going to go as quick as we can for time management, but try to add some serious value to this if we will. There we go. So a little bit about who I am. It's 19 years now in pest management. I am a dealer mechanic by trade. Now I'm a pheromone dude. This is my buddy here, Eric Myers, who got me into pest management. I've known him since I was 15 years old, and he is a classically trained professional chef. Now he's the global sanitation manager for ADM Corporation. So I had good teachers in the infancy. Obviously, Ed Hazada is one of those. And I wanted to go forth, and this is my 19th year. I just got off the stage at the National Conference of Urban Entomology here in Salt Lake City. So right from that talk to this talk. So while this one's a little different, I'll try to make sure I don't marry the two, but that's a little bit about who I am. So some key points we're going to discuss here is what is mating disruption, basic, how does it work, how should you initiate and use it, and then what do you do with the information you're getting or the results, or how do you evolve this program into what we're trying to do in this modern world is prevent insect infestation. Sure, we want to manage them. Yes, the products that you guys produce do grow in the dirt, right? So we understand the risk of certain insects and things that come from that process, but how do we prevent as many as we can? And Ed did a great job bringing this conversation into the fold here. So the biggest one we're going to start on is what is mating disruption, and there's a lot of different products that are out there on the market. Mating disruption has its roots in the agricultural world. That would be like navel orange worm mating disruption, DA-MEX, which are like pear ester-based products for codling moth mating disruption, oriental fruit moth. The list goes on and on and on. Well, about 2007, 2008 is when mating disruption became commercially available for the post-harvest world for Indian meal moth. Two of those products are right here, BASF Allure MD, which is a satchel-based product with a pheromone kind of contained on the inside. And then we have Sidetrack IMM mating disruption. And the polymer is proprietary to our company, and it was cut its roots in the ag world here for longevity and performance. We also have now aerosoling style units that have been used in orchards for the longest time. Now it's something that's available on the market. And then down here is a product from the United Kingdom by Russell IPM. And that's their offering of mating disruption, although I don't believe it's very widely available in the United States as it stands right now. So I always like to cover the kind of the gamut of the different technologies. All of them have features and benefits. Talk to your distribution channels and your applicators to source these things out down the road. By all means, of course, we're available for other things. So for our corporation standpoint, mating disruption, we offer 3 different styles of IMM mating disruption. Cigarette beetle mating disruption is on its way and through the EPA registration process as we go forward. Not a big pest in the almond industry, but in general, it's a large pest, the second one to IMM. There's the small dispensers, which are perfectly fine. There are large dispensers, which are 2 different options. One is extremely less time and labor. And then now, as of in the middle of the pandemic, we thought it best to launch our liquid microcap, which is IMM-MEC, based off of our codling moth microcap that's used as a pheromone adjuvant for insecticidal applications in orchards. So there's a lot of different things and different ways you could use it. They all carry a pesticide label by law, but by the rules of science, they're really not a pesticide because they're not killing anything in general. They are relatively non-toxic. They're passive, except for the newer ones that are aerosoling, certain volatiles into the air. Those ones aren't passive, but the other ones that have traditionally been a passive dispenser where it just liberates out into the environment. And there's really no risk. So there's only really one country that doesn't regulate these as a control product, and that's Japan, which is crazy because Japan is extremely regulatory. They love to regulate things, but they understood the chemistry of pheromones and mating disruption. It offsets traditional toxic pesticides that are used, and it's more holistic to the program. Not to mention, there's some that are organically certified as well, but I've never had a problem with that. There's the Washington State Department of Ag. We discussed that. That maintains a registration status for pretty much all of our products under the NOP guise. And then BASF's Allure MD product is OMRI listed as well. You don't need this in an organic program. It does kind of help in the infancy, but as long as you are filling out your standard operating procedures of how you're trying to protect the organic product's integrity and not adulterate it with a pesticide or an insecticide or adulterant product, you can usually plead your case. And I've had a lot of certified organic agencies approve a lot of different products as long as the specific needs are met and we show that we're trying to maintain that stuff. So don't worry about that. Always ask those questions. So benefits of mating disruption, and there's a whole bunch that might not even be listed, but at the end of the day, the facility downtime is a huge factor of how many hours do you have to shut down for traditional insecticidal treatments. That doesn't mean you shouldn't do them or use them into your program. It means that this return on investment has to be calculated, because sometimes, and I know this from my time in pest management, 11 years, that certain bakeries, it's $1 million an hour in revenue when those baking lines are running. So the shutdown for a $20,000 insecticidal treatment is nothing to them versus the time it takes that facility to be down and not in operation, and especially not in operation and not cleaning. It is extremely low risk, can be done when the facility is in operation. For the most part, all of this mating disruption is akin to hanging a piece of plastic in some type of securing facet. Like I said, there's newer ones on the market that involve more mechanical stuff and battery power and blowing stuff around a facility. But for the most part, like we said, we have passive dispensers monitoring, no aerosoling or spraying. Prevention based is key. We've had clients put this in when they don't even have an active problem because they deal in an industry where they have extreme susceptibility to these bugs. So they understand that they're going to, and you guys fit that bill for that, you're going to end up with Indian meal moth eventually. So might as well, just like you have rodent monitoring systems and pheromone monitoring systems, you might as well employ mating disruption as a preventative. So when you do become infested or have activity run through the facility, you already have a defense in place. There's no real resistance or tolerance to mating disruption. It's their own synthetic chemistry that's emitted by the insect. And then we talked about the two that currently that I'm aware of that are certified organic. Next thing is, how does this product work? And I'll check my time here just to make sure. Okay, cool. I'm going good. So mating disruption modes of action, and I break it down to this because, just like Ed, I'm an old service guy here in the food safety pest management realm. So modes of action are a big thing to me. How does the product work and how does the active ingredient control? So the first thing is sensory overload. There is so much pheromone into the environment that the insect physically doesn't know what to do. So usually this means the male moths are stuck onto a wall, a piece of equipment somewhere, and they physically don't fly. They die there. You touch them and they fall to the floor. So sensory overload is what we want most in a mating disruption program because that's going to give us our best result the quickest. Next is false trail following, and that is the illusion that the male is honing in on the female who's in a budding position emitting that sex pheromone, and he just can never find her because she's not there. There's so much pheromone in that volume of space that he is unable to locate that female, thus giving us that other mode of action. And then the last one is delayed or denied mating. And this one correlates to a Dr. Subi journal article from K-State University about the delayed fecundity. That is the reproduction rate of a female. Every day you delay the male from mating with the female, you average 20 to 25% reduction in that fecundity or ability to have fertilized eggs. So dare I say, day 4 or 5, if and when that male finally did find that female and they actually do procreate, it should be a very small brood of progeny that emerges from that act. So, and these insects don't have mouth parts. They cannot consume anything in their adult lifespan. They have one job, and that's to mate and then drop fertilized eggs onto food products or near there. So when we understand that, that's how mating disruption can be so successful. The key to this is the understanding the managing expectations of the client, whoever that may be, the pest manager or the actual quality people in the almond facility, is they have to understand mating disruption is not a kill style insecticide. It is a suppressant or a life cycle mitigation tool. It only affects the adult male. It always is effective, but if you bring in a hot load of almonds to a facility that are infested, you're going to have flare up because it's going to have to take time for the males to go through these 3 modes of action to get some results. So it's not a magic unicorn, but as someone from Purina, Nestle Purina products said a bunch of years ago in the infancy of this product, it's the closest thing we have to a silver bullet for Indian meal moth, and that's a longevity approach. So here's a pair of mated individuals we see right here. These videos are from YouTube. Why work harder when you don't have to, and it's publicly available. Ed talked about the field expedient way of larvae differentiating from Lepidoptera to Coleoptera, but a female's here, a male is here, they're in a mated position, and they're on soft red wheat. The next video is another one from YouTube, which is an injured female. That is an ovipositor coming out of the bottom of the female. Those are her eggs that she's dropping. She's been injured, so this is a biological response to being injured, and she's just dumping those eggs in hopes to pass along that genetic material down the line. But you can see those eggs are super small. So is that ovipositor. It can get into small spots. Those eggs are about the size of a grain of sand. She'll have 200 to 400, depending on all kinds of things. And if they're fertilized, like Ed showed you the population growth chart, there's a reason these insects can beat us in the long run, is they just outproduce us. They can't compete with us on any other level than production. The next 2 slides are the best examples of selling that I've used when I was in pest management industry and now as a manufacturing representative for the lay person. I don't classify anyone that's on this call. You're already taking the steps and time to further educate yourself. But maybe it's someone else in the organization, or if you're a pest management company, maybe it's your client that needs to understand these expectations. These are the best 2 to use. Female Indian meal moth on food products in a warehouse. Male Indian meal moth locating her scent that she's in a budding position, releasing that odor. And she's going to want to do that and deposit that in competition so she can detect other insects, her other species emitting their female sex pheromone. She knows that. So she's going to try to go to an area where she gets an advantage. She's going to bud. That male finds her plume of pheromone and he locks in and we have reproduction. Next, we install properly mating disruption into the structure, and that doses on usually volume or square feet, depending on the products that you're using. Again, you have to read those labels. They're not big labels. Maybe a paragraph applies to the true application of it. But when done properly into that space, this male now cannot or is delayed in finding that female. Therefore, we get either significantly reduced population growth or elimination in general. And that's what we call like the 30-day crash after mating disruption comes in, because you just annihilate all those males. But what's behind the males? Eggs, larval instars, and pupation cases, which are going to become either males and females. So you need to understand the biology of the insect a little bit, because it's only affecting the adult male. So it's going to keep working until you get to that low grade. So those two slides are in theory the best things I've used to translate that information to people in this industry. A little bit about the principles of mating disruption steps. Again, you need to read your EPA approved labels and products. You need to seek the advice of your distributors and those that are licensed professionals in your areas, and they'll bring in manufacturing reps as you need to. But in general, the three main mating disruption steps: you need to have a complete calculation of the volume of space. And for example, the product I recommend, or I represent, if you will, is Sidetrack IMM, and that dose is in cubic feet, real cubic feet, not removing a load factor based off of equipment in a facility, or a load factor of, say, the ceiling is 50 feet, but product only goes up to 25 feet. So therefore we fog to 25 feet. So we remove the rest of that load factor. You cannot do that with a chemistry that has equilibrium and volume of space. This product is going to adulterate and become complete within everything under that roof and every air around there. So you need to calculate QC rooms, quality rooms, offices, restrooms, annexations, if they share a wall or a door. That all needs to be under the proper calculation of that cubic feet in this scenario. You don't need to put dispensers in those areas, but you do need to calculate that cubic feet, because otherwise you're handicapping the application and you may not have the proper amount of mating disruption in the entire volume. Because just like a fumigant will reach equilibrium in that space, the pheromone chemistry will as well. So that establishes how to get your proper volume. That's probably the hardest part of this entire job, as opposed to selling the client on it or your management team, is the true calculation. I use a lot of Google Earth for this, because as a fumigant, old fumigator and fogging person, ULV stuff, I'd spend a lot of time measuring and laser tagging, and because you're very precise, because you're applying a true toxic pesticide. You want to steward it properly. Well, pheromone chemistry, I want the big picture of the building. Even if there's big air handling units, I want the volume of space they occupy, because they're going to suck away chemistry from my entire structure. I need to account for that. I use a lot of Google Earth measurements of there, and maybe inflate or come out to other areas, because I need to ensure that you're going to have some loss due to the convection of the building, but that's what the dispenser's job is over the time through the label. That product is going to keep producing the pheromone and emitting it, maintaining that saturation. The next, whatever application rate is on that level, that is commensurate with the infestation or risk that you have at your facility. You all are in a raw agricultural commodity, that is almonds taken from orchards that go through a hulling process. So I would classify you as a high risk, just like coffee, cocoa, spices, and tobacco. The nut industry and dried fruit industry falls into high risk of susceptibility. I'm not telling you anything you don't know. That means you should be starting off by not handicapping yourself with the highest application rate that you could afford, budget, or get into your program. Always say you could start higher and come down. It's harder to start lower and then ask to increase something. So we want performance. So you can, at 6 months is the eval for one of our products. 6 months, you assess your program out to a year, those kind of things, and you trigger your next replacement of that product. You could always go down as you get better control. It's harder to go back up because you're behind the 8 ball, if you will. And then distribution of your dispensers or of your product in a grid-like pattern, or as the manufacturer dictates. This is the KISS method that I follow in life. Is keep it simple, stupid for myself, because the distribution, you can overthink this, and we used to think way back 18 years ago, or shoot, it's almost 20 years ago now, that we had to be very specific where we place these things. Well, it may dose one dispenser per, let's say, 14,000 cubic feet, but you don't put that dispenser every 14,000 cubic feet, because to place something in a volume of cubes doesn't work in the realm of 2D. So you can't do that. But what you can do is put it into grid-like patterns where a normal person can reach the product and apply it is perfectly acceptable. We rely heavily and it's always a benefit to this program to have any airflow. That's humans walking by, forklifts, tow trucks, HVAC systems, fans, ventilation, doors opening, shutting, you name it. Airflow always means better movement of the chemistry, which means better results. So some of our tobacco trials, they have very sophisticated HVAC systems that control humidity due to mold and moisture and other problems. So they cycle air sometimes every couple minutes into that entire structure, and mating disruption still works because the dispensers are doing their job and the space is constantly moving that chemistry around. The chemistry of the IMM pheromone, very, very social. It loves it to fats, plastics, and then re-releasing. So the pheromone itself is very pleasurable, if you will, for it to operate in our styles of environments hanging on. So don't overthink this. This is purely let the environment dictate the placement, and it should look like a grid on a map or schematic when you're finished. That's it. If you had to put 100 dispensers out, and I know a lot of the almond facilities have the roof girdered system where there's no support poles, it's on the load bearing walls on the outside. You don't have columns or racking throughout the middle. So there's a lot of things you can do where putting these dispensers on the wall may not be grid-like, but you can use cones, racking cones. I know you've all been in the school areas where they have the school speed zones and the little turtle that looks like he's running out in traffic holding a flag. We've had some where we recommended buy 10 or 15 of those, put them throughout the facility, and you could hang your monitors or your mating disruption on that. And it looks like a child, so maybe a fork truck driver that's prone to smashing into things, and who you are, who I'm talking to, they may not hit that because it looks like a kid, or they may have some repercussion in your policy or system or your employment. So there are options. Don't just think because you have nowhere to put them, you got nowhere to put them. There's always a will and a way. Please reach out to people in the industry and the market, and we'll help sort you out and solve that problem. And then the last conversation here is the evaluation and interpretation. This is probably the biggest letdown that I see. It was the subject of my talk here at the Conference of Urban Entomology, is the lack of using data to verify a treatment. As an industry, we need to get better. And I say industry, meaning the pest management side. We need to get better at understanding and evolving and using the data to solve our problems, reassessing that risk. So the best way, and I know time is of the essence here, and I always try to talk a little quicker. This goes back to, and I could have showed you 1,000 different graphs and charts. I like this one because number one, it's San Fran. It's when the product originally launched of Sidetrack. It's a chocolate processing facility, and it's a ton of activity that's out there in the Bay Area. These are all deep treatments. Now, of that product line, I do not think it should lose its registration. It is a great life cycle mitigating tool. It has a very high vapor pressure. It's now, thanks to Cardinal, able to be prepackaged with certain growth regulators, which is even better. It's an outside release stepped program with remote release, so the risk for an applicator goes way down. The advances in safety, health, and then control are just all in it for DDVP. I'm a fanboy of that product. Here, it might not have been used as correctly, or it just could have not maybe overcome the life cycle. What does a fogging product do, or a ULV versus a fumigant? A fogging or ULV based product is a life cycle mitigator, exposed stages of adults and larvae. That is what your target is. When you fumigate something, you are trying to have a kill step, which means kill all stages of life and you start anew the next day. If you constantly have to fumigate the same product, you're not having a kill step. You're having a failure, as Ed kind of talked about. So there could be a part per million problem, a CT problem, an absorption of fumigant problem, a leaking or crappy fumigation technique problem that is very prevalent in the industry. Time is money, and people keep rolling through jobs. But that's the difference between fogging and fumigating. But here we're trying to mitigate that life cycle of exposed stages of adults and larvae, which it's having a result, I'm sure, because it's done by a professional applicator that I know and trust. But at the end of the day, you could see the month-to-month data here. A little bit of a knockdown here, and that's just June, July, but I mean, August, September, I mean, it's those foggings are having no real measurable effect on the cocoa beans in this facility. And it's a raw agricultural commodity that's imported. Yours is grown in California, of course. It's not imported. You export it. But at the end of the day, it's very similar in the susceptibility of that product. The next year we see in blue here, mating disruption was installed in March to the label maximum for that facility. And you can see the blue. It's just proof that it is a more holistic, integrated approach for managing the Indian meal moth on a prevention-based long-term tactic. You still have some treatments like they do here. And the funny part is, talking to the person that ran this research demonstration way back in the day, these two treatments were not made because of life cycle growth here. They were made because mating disruption was so new that they didn't know how to describe it to an AIB auditor, that they weren't fogging and they can use mating disruption. So they did these two just to kind of shut the auditor up of like, hey, we did 2 of these treatments. Oh, okay. So you still did some foggings. Great. And hey, you have to handle that in the real world. And I get it. Audit inspections, the standards that you have to hold, interfacing with those people. I totally understand it, and especially the GFSI style audit schemes. So we just had questions come up out of California. I believe it was Eurofins asking if pheromones were food safe. And I had to try everything not to laugh, because are the boots on your feet inside of an almond facility food safe? Can you eat the boot? Can you eat your clothes? I mean, they're in the facility with the pheromone, and I get what they're trying to ask, but again, it's an education problem on there. And I've approached the issue with the company Eurofins, and we're going to be doing some training with them, like we do with all the other auditing stuff, of letting them know what monitor systems are. But I knew what they were meaning. They meant, if this gets into the food stream, is it safe? And my answer is no. But it shouldn't be there. It's not a scoop. It's not a bin. It's not a conveying system part. It's not meant to be in the food stream, just like the pen that they write on when they walk through the almond warehouse. That's not meant to be in the food stream either, and you should have programs and policies to mitigate that. So I'm digressing down a point here because it's just one of those things that I always get new information that comes down. But in the end, you have to constantly look at this data, see where you're at, and make a change. The biggest thing, and this is the most recent, in the coffee industry in New Orleans, dealing with a director of quality who is, she's a Chinese American, and she used to work for a decaffeinated coffee huge manufacturer. So she had a very big policy program, and now she's on the agricultural side of, coffee import, export, and storage. And she just couldn't fathom that when they brought in and filled up half of a warehouse with new import coffee, that why did my insect counts go up for Indian meal moth? And she thought mating disruption stopped working. And that's her thought process, and I understand it. But what I had to go through with her is, you brought in half of a warehouse full of susceptible and infested goods from import that were either improperly fumigated or not, who knows. But at the end of the day, you expect it to immediately give you that same result. And it's not going to do that because it's affecting the male species only. It's going to work. Give it a couple of weeks and you will get some control. But in the interim, I asked her, well, if you would have fogged the day before, cleared the fogging, opened the building, and brought all this new coffee in, would you blame the fogging for failing? And she said, no, because it already dissipated in the atmosphere and the environment, and we already cleared the fogging. And I said, great. Well, mating disruption doesn't go away, but it doesn't just automatically work. So you have to understand the difference of the two. And again, managing the expectations of the people that you work with, work for, or have to report to is a big thing with mating disruption. And dare I say, that's the biggest failure, is the failure to manage the expectation of what mating disruption does. Because once you understand it, you understand it's a piece of that tool and it stays there, especially in susceptible industries like fruits, nuts, tobacco for cocoa moth, spices, coffee, chocolate processing, and then you get into the baking side. Indian meal moth is the #1 pest in the world, and there's no reason for that now that we have all of these commercially available mating disruption products. So in the end, we have 38 years of innovating and investing in your success. Please reach out to your distributors. If you have a question for me, you can say it here. You got my contact information down the road. Due to the whole pandemic, I haven't been out in California that much, but I'm making my way. And as I'm out there, reach out to your distributors and I'll work with you. Appreciate it. Thank you.
Thank you, James. And again, a wealth of experience speaking. Thank you. I'm handing it all over to Vijay.
Great, thanks. Can you see and hear me?
Yes.
Okay. Appreciate it. Yeah, my name is Vijay Pai. I'm the general manager of the commercial pest products division at Sutera. First, I'd like to thank the Almond board for hosting this great event. Very important and timely discussion to be having, obviously, with supply chain interruptions resulting in finished products sitting in facilities longer, the need for innovative tools and effective new approaches to solve pest control problems is needed now more than ever. So I'll be talking about mating disruption as well. James gave a great primer about some of the biology, behavior of the insect and everything. So I can focus on the product, but also before getting into the product, maybe I'll just quickly talk about Sutera as a company. So just quickly, Sutera, for those who may be not aware, we're wholly grower owned by the wonderful company, but we operate independently and provide the industry with innovative pest control products. So Sutera started with pheromones back in the 80s, and we have a rich experience and knowledge of pheromone chemistry, entomology, chemical ecology, and we actually invented the aerosol pheromone mating disruption products, which is kind of the gold standard for mating disruption in agriculture today. So we have to date, products on 25 different countries, millions of these deployed worldwide. So specifically, our facility, we're based in Bend, Oregon. We have the largest dedicated pheromone facility in the world, and again, we're U.S. made, but our products are proven high quality, innovative, and since we're grower owned, we can get that feedback back and deliver some innovative solutions to the industry. So just enough about the actual company. Now we can talk about the actual good stuff, the product and mating disruption within the almond industry. So just last week, we launched a new product. It's a very exciting time for mating disruption. Obviously, who you just heard from, James, they've got a new product as well. So in the matter of, 1 year, 2 years, there's 2 new products, and we're seeing the industry really adopt this as a preventative solution. So again, very exciting time for mating disruption in stored facilities. So the product that we have is Checkmate Puffer IMM. It's the world's first automated aerosol pheromone emitter within the stored product segment. So provides control for Indian meal moths for about half a year. So the benefits for all mating disruption products is it's environmentally friendly because it uses this non-toxic pheromone synthetic to employ mating disruption as a mode of action, as opposed to traditional insecticide methods. And it can be used in all areas where stored food is held, such as food manufacturing, processing, storage, distribution, even in retail spaces. So very relevant for the folks on the call today within the post-harvest almond industry. So one of our devices is good for about 7,000 square feet, and I'll get into some of the specifics on the deployment. But again, I think Ed spoke to this, James did as well, so I'll gloss over some of the specifics, but the pest we're talking about is Indian meal moth, the most common moth in infesting stored grains, and very, very relevant for the almond industry here, as you guys all know. But specifics of the actual moth, quite easy to identify, about 1/2 inch in length, and they have that peculiar, markings on their distal forewings. So the adults are non-feeding, short-lived, but the females can lay 200 up to 300 eggs, and they would be laid near the food materials. So the adults, although they're the ones that lay the eggs, they're not the ones that do the damage. It's the larvae, which are about 1/2 inch when mature. And not only do they feed on the important material, such as almonds, but they'll leave behind frass and a silk invisible thread, which contaminates the food. So this, along with the overall damage of a high value product, makes this a very, very serious pest. And then again, quickly, the what the mode of action is here that we're talking about with both what James discussed with the dispenser products, but also with our aerosol device. We're talking about mating disruption which is a method that's not new to the pest control industry. It's been used for years, decades, to prohibit mating. So the male moths use sex pheromone to locate and mate with females. And what the product does is it disperses the species-specific pheromones in the air that, in kind of layman terms, confuses the male moths so that they're not able to pinpoint females, thus inhibiting mating, reducing offspring in future generations of pests, essentially achieving control over the year. So more scientific, and James did touch on this as well, but the pheromone replica that we're putting out into the air, in our case, puffing or dispensing, works via sensory overload, making it so that the male moths, there's so much pheromone in the air that they can't process. There's also false trail following, in which the male moths can't find the actual female, which you can see represented in this picture here. And then also just kind of delaying mating or outright denying it. Again, no mating equals no offspring, and that means a reduced pest population. So getting into the specifics of the product, I mentioned it's an automated aerosol device that lasts 180 days. So when the device is turned on, it puffs pheromone into the air automatically every 30 minutes for a full 24 hours a day. One device covers 7,300 square feet. So these can be hung from rafters. It comes with a hook along with an aerosol can and 4 AA batteries. So when you get it from the manufacturer, you just turn it on and it'll puff that aerosol into the air. The product is EPA registered, as well as registered in the states of California, Washington, Oregon, and Idaho, as well as Colorado. And we're actually expanding that to the rest of the states by the end of this year. So it can fit into, your food safety and IPM plan. And as Ed mentioned, there's not really a silver bullet. There's a whole bunch of different solutions, and this is a great tool and solution to fit within whatever your IPM plan is. So specifics to the product with regard to some of the usage and considerations. It does come pre-programmed, so all you have to do is take it out of the box and turn it on. The device should be hung at least 7 feet off the ground. Best practice is to put it above the level of the commodity you're protecting. So sometimes in these warehouses, what we've seen from deployments this year, bins stacked 3-4 high. You can put these above those bins, but it comes with a hook, and sometimes a lot of PMPs I've seen use these magnetic hooks that this product can hang quite easily from. So also common sense applies here for deployment. You don't want to place the product, directly spraying towards a wall or under a suction hood. The air helps distribute the actual pheromone chemistry throughout the building. So you're going to want to not put it against a wall, obviously, or open in front of or directly on top of open food sources. From a, chemical residue concern, this class of chemicals, straight chain lepidopteran pheromones, are considered exempt from the tolerance levels in the US, and in the EU, they're actually exempt from residue settings, so the product can be used in these facilities and used while workers are present. So Sutera has a full technical field team that can help if you guys are interested in the product and need some help in how to deploy this within your facility. If you have a facility map, what we've done already this year with plenty of our customers is help them mark on their map where they should be deploying this. So we're happy to do that for anyone that has questions. And of course, you'll have my contact information. You can reach out. But once up, the device doesn't really need to be checked or played with for the full 180 days, and will work. And then just, again, in terms of the full IPM strategy. This isn't meant to completely 100% eliminate all other things that you're doing with your IPM plan. You know, prevention, avoidance, suppression, monitoring, all of these things should be continued. This is just a great tool to help with this terrible pest that you guys probably all are dealing with. The last bit here before I conclude is just a few examples from case studies we've done with this product. We've done about 4 to 5 years of R&D on this product. Really speaks to Sutera's kind of depth of wanting to make sure that a product is ready for the field and can kind of survive and last out in the field on the best conditions. So we've tested this in about 6 different countries and different food facilities, not only just almonds, but also wheat and coffee and other commodity holding facilities. So this one that you see on the screen is a quick look at a 3-year case study we did in the UK with a wheat processor. They had a known Indian meal moth infestation. Yearly, they were looking to also reduce their need for fumigation sprays and the costly shutdown time that those fumigations cause. So they approached us to try to field test this product, and we suggested a long multi-year study so that they could actually see the product working season over season. So we deployed 2 of these puffers in 2 different mills and compared it against a control. And after, as you can see from the moth catch data, after a few years, you can see a consistent level of control being achieved from that trap inhibition and lowered trap counts. So another one that's probably more relevant for you guys on the call here is one within the nut processing facility. We did this one a few years back, actually, and this one shows just a year of efficacy. A potential customer reached out to us wanting a solution again to try to cut down the amount of shutdown time they had for fumigation. So they wanted to see if they had a more preventative control method. So we agreed to do a trial with them in their one of their many facilities. It's a huge facility, but we put about 8 of these puffers in 100,000 square foot facility and achieved that control, as you can see from, again, the male trap counts here on the screen. You can see the reduction and the high level of efficacy achieved from the populations continuing to remain below the threshold for treatment. So after the trial, the customer was interested in implementing the solution, but unfortunately, the time for approval from regulatory, as I'm sure Ed and James also know on the call, takes quite a while. So we weren't able to deliver the solution. But now, as I mentioned just last week, we have launched the product, and it's orderable now. So this customer is now. So just quickly in summary, our product specifically is the Checkmate Puffer IMM, deploys that mating disruption solution for large facilities, ideally, given our aerosol technology. It can lower the insecticide use that you have, and then the real value proposition, again, that we saw from some of these customers is a reduction in shutdowns and the no reentry periods and everything else that comes with that. So yeah, that is kind of the short of it. Keep it brief this morning here, and if you do have questions about the product or want to reach out, feel free to visit our website. I think Gabrielle mentioned we'll be staying on the call at the end to address some of the questions, but you can reach out to me or anybody at Sutera. Thanks.
Thank you, Vijay. So as you see, there's various tools here, very similar, to help do mating disruption within your facility. I'm just going to talk a little bit about some regulatory issues, if I can share my slides. basically, as we're talking about this, sort of taking just a reminder, why do we need to worry about maximum residue limits? One of the big issues we face with almonds is just simply that even at the warehouse stage, certainly growers don't, but also at the warehouse stage. Can you go to the next slide? Well, here's the big reason to worry about MRLs is tree nuts go everywhere. I use this slide just to give you a sense of sort of the trade of tree nuts. That big red line from the United States to Europe is almonds, just to give you an example, but it really gives you a sense of why paying attention to the international regulations is such a critical component to being able to sell product. Next slide. And as I was just saying, one of the issues we face is that it's hard to know where those nuts are going. So almond growers really don't know, huller shellers generally don't know, and even handlers, at least at the time they're doing some of these facility pest management decisions, they don't know what markets their nuts are going to go to. So that makes it hard to do anything specific to a single market. Next slide. And just a reminder of what an MRL is, a maximum residue limit. In the United States, we call them tolerances. And that's basically the number that the maximum amount of pesticide residue that's legal on a food or animal feed item that's in trade. And generally it's set based on whatever the maximum labeled rate is. In international speak, they use the term GAP, or good agricultural practice, for maximum label language, and it's commonly in parts per million or milligrams per kilogram. And in general, you have to have an MRL, or in the United States, we have something called an exemption. Actually, other countries have this too, exemption to a tolerance in place before you can use a compound or pheromone, for that matter, for domestic and international trade and have it in the marketplace. And one thing I like to keep reminding folks is MRLs are trade standards. They're actually not health standards. Yes, there's a risk assessment behind it, but it's more to make sure that that number is okay. The number itself is not based on any particular health standard. Next slide. So one of the issues, and I have to admit, putting the slides together, is when it comes to trying to find the MRLs for post-harvest and facility uses, it's actually not as easy as it is for in-field uses. So just to give you some examples for where to find a tolerance in the US Code of Federal Regulations, you can find tolerances under almond post-harvest, under tree nuts, under food handling establishments, food commodities. So here are just some examples. So for cypermethrin, they basically have food commodities and feed commodities. For those where they don't already have an MRL, in the case of this one, they have an MRL set for nuts and tree nuts, or for tree nuts. For piperonyl butoxide, you have almonds post-harvest, so specifically saying this is for post-harvest use, the MRL. For lambda-cyhalothrin, you have a specific MRL for almond hulls, but then for the nuts, it's hidden under an all food commodities from food handling establishments where food products are held, processed, or prepared. So just realizing that one of the first hurdles, in addition to knowing chemical name, is knowing what to look for, at least in the United States. Next slide. And even using the global MRL database, at least the publicly free version available to those of us based in the United States, that MRL database is based on US tolerances, and they don't do a good job of capturing these facility use compounds. So like when I looked up resmethrin, it has, according to EPA, it has a facility use MRL, but when I look in the global MRL database, nothing shows up because, again, they don't have that in there. So you might be better served actually paying for the global MRL database, which will give you MRLs regardless of what country you're starting from. So that might give you better data than just the free version that's available to those based in the United States. Because as I say, there is actually an MRL in Europe for it. So this is just the global MRL database, generally a very good resource and still a good starting point, but just realize that for facility uses, things are messier. And then I sometimes go straight to the EU MRL database. And again, typically Google searches for EU MRL database will get you there. Next slide. And then just to sort of say, just give a heads up. So based on Almond Board does residue testing, and this is also back in 2007 and 2008, USDA AMS's pesticide data program actually took almonds from the retail and tested them for residues. And the facility use compounds that pretty regularly do show up are dichlorvos, vipona, the piperine butoxide, as well as the MGK 264. And the reason I mention them, for all of them, we have some MRL issues. So vipona, EU, Korea, India, the MRL is 0.01 parts per million, and the residues sometimes are higher than that. Piperine butoxide and MGK are synergists, and in the EU, while they've harmonized the MRLs for what they call plant protectants or pesticides, they have not harmonized the MRLs for synergists. And even though I know that there have been efforts to try and get harmonization for piperine butoxide, at this time, some countries have an MRL and some countries don't. So it's very confusing. And it's, again, not that easy to figure out who has it, who doesn't. The other issue right now is South Korea moved to a positive list system for tree nuts in 2019. I'm losing track of time, 17 or 19. And they, as of January 1, they were using a default tolerance for piperine butoxide. We know that a data package has been submitted, and we're trying to get some data about where things stand. I gather there's been some changes in the leadership there, and so trying to get some more clarity on that. So just to give you a sense, those are some compounds that we have had there's some potential issues with them. And so the reason we say that is just, I'm reiterating what you already heard from the previous speakers. This whole facility use pest management, the first principles are practice IPM. And that is, figure out how to minimize the chances of infestation. Ed mentioned this, James mentioned it. And that may also be meaning managing, looking at what's going on outdoors. As Ed mentioned, are there places the bugs can come in or the rodents can come in, but also looking at, do you have a hull pile? Do you have something like that that could be a source of these storage insect pests in ways that we haven't thought about? Monitor regularly. Again, you heard that again, principles of IPM. Assess where mating disruption will work. And then use pesticides judiciously, as again, you've heard from others. And then one other thought, given the fuming, fogging actions of these compounds is, to what extent can you really make sure that the nuts are not there when you're doing that, which I know is wishful thinking, but I'm just saying. The other one is really making sure that any containers with the nuts are well sealed and covered before doing it. And then don't have any data on this, but maybe want to consider wiping down some of the key contact surfaces after a fogging operation, just to minimize the chances of residues getting onto the nuts. So with that, next slide, we're moving it over to questions, and I will start, and this may be for Ed and James and Vijay, as Patrick asked the question of best times to fog, fumigate a tarp pile, probably more Ed question. No, in terms of where sunlight, you don't have those inside the facility, but to what extent do you see that, what you call the circadian rhythm, within the facility as well as outdoors?
Well, what I do know is I've read some articles on circadian rhythm of stored product insects, and you can't change their circadian rhythm overnight. It's a process that takes a while. So if you're looking at ideas such as manipulating lighting to make them more active, that may not work over a short period of time. I can tell you from experience that just even recently, I had an Indian meal moth outbreak in my garage from bird seed. And every evening at about 9 or 10 o'clock, they were flying like crazy in my garage. The females especially like to fly at night. Same thing with red flower beetle. They'll fly at sunset. But then if you have warehouse beetle likes to fly about 4 hours after sunrise. So it depends on the specific insect that you're going after. So, so by trying to manipulate their circadian rhythm, I don't think will work, where you can just turn on the light and expect their activity to increase immediately to do a fogging treatment. So that would be my comment. It depends on the specific insect, and I don't believe you can manipulate their rhythm just overnight.
James or VJ, anything to add to that?
No, so the differentiating, the question, you can hear me, right? Just want to make sure. You can hear me? Okay,
Yeah.
cool.
Yeah.
When he mentioned, are there environmental factors to introduce that can make the pest more active during fogging period? So the different fog and fume, right? We need to be very careful at those terms of interchangeably. So fogging, I'd argue, the more active the insects, the adult stages, which would also be most likely some of the larval stages, although they're consuming the protein content. For aerosol, ULV, fogging, misting, you want them more active. So the more they are socially out in the environment, like Ed showed that gradient scale, I would argue the better, because you have the chance to expose more of them to that droplets that are misting from the environment. Whereas the fogging is 100% in line with what, again, Ed posted there, is you want to strategically apply that to where that is. And taken from the almond hull pile to the almond processing facility, right? The feral populations are a big factor of risk against those structures. So, I don't know what there is as far as perimeter treatments or the best practices for keeping them out of those structures, but controlling the hull piles, because that's a byproduct, right? Essentially, it's usually either feed in or fertilizing product or shipped somewhere else, but they may be contributing to more problems inside of a facility. So I'd probably escalate that risk a little higher as to where they're placed in difference to light, how you're mitigating it outside, and those kind of facets. But always understand the two are totally different: fog, ULV versus fumigate side. So fumigation, yep, you want them to stay not active so you could seal them into that structure. So that's it.
Thank you. Any other questions from the audience? And while you're thinking about it, I'll just ask one question: is, with the mating disruption, how does it work for the monitoring tools now versus the mating disruption, or for those traps? How does that work now? Well, and again, others get ready for questions.
Mm-hmm. So that's I'll just go off real quick. That's an age-old question of, if you're using a pheromone to detect and then you use the same pheromone to try to disrupt, do you not have trap shutdown? And in the ag world, orchards, 100%, calding moth, navel orangeworm, some of those things do have trap shutdown when you deploy mating disruption. Since 2007, mating disruption has been used from IMM. That's what we assumed. We've been proven incorrect. The only time you're really going to get trap shutdown is where a monitor doesn't work, is if you adulterate over that monitor. So say you place a dispenser directly above a monitoring system, well, that you're washing it out. And I liken this to a dispenser is like a jet engine being turned on, whereas a monitor is like a cigar wafting smoke. They might be the same chemistry, but it's different plumes that contact the insect to interact in different ways. So if anything, the dispenser is more of a repellent because there's so much AI on it, whereas the monitor is the plume alluring agent bringing them in. And as the data, VJ showed the data, I showed some of it, we can go ad nauseum. The data or monitoring means even more during mating disruption than without mating disruption, because the fact that you're making captures in the IPM program means you're probably closer to the active infestation and you can root it out holistically instead of leaving it there to go through its life cycles. Our biggest case study was the retail pest market. We did a 5-year comprehensive work with Dr. James Campbell at USDA ARS lab in Manhattan, Kansas. And those are retail stores that are heavily infested with Indian meal moth. And all we used was pheromone data. So if there was trap shutdown, we would have never been able to get any type of a control because we wouldn't know that. So that and to sidetrack that, no pun intended there, egg laying of the females that have been fertilized. James Campbell hypothesizes that the correlation to fertilized females is the same as adult males captured in an IMM monitor during mating disruption. And for 5 years, he's worked out with this hypothesis of we've done oviposition or egg laying dishes during mating disruption. It's not necessary anymore because if we can catch the males, we can estimate the amount of females that were fertilized by the captures of males, and it almost always equaled out to his egg laying dishes. So we've learned that the product is still working. There's no issues with the trap as long as you're using the monitors. Our estimate is 10 to 15 feet ish. You should be away from a monitor with a mating disruption device if you can help it. But even in beetle, one column will have the mating disruptor because there's nowhere else to put it, and we still have activity. So we're still able to measure the activity and results and go forward. So.
Yeah, I'll just quickly add the bit about trap shutdown. We refer to it often as like trap inhibition, to James's point. So yeah, totally agree with what he was saying, but I think it's also a great starter for conversation that monitoring is kind of the bedrock and the important part of all IPM. So just to continue to emphasize, that's going to be the information that informs almost all treatments and everything, and if your mating disruption's working or not. So just goes to show, make sure everyone's got their trap and lure out there.
So any other questions from the audience? You can raise your hand or unmute yourself, I think. Well, with that, I just want to thank very much Ed, James, and Vijay. And remember, we've got the questions that need to be answered if you want to get continuing education units.